TV, and in this video I'm going to be continuing our sort of scrolling thing that we did that I did in the last video, and this time I'm going to include a highly requested feature. Unfortunately I accidentally deleted the example I was going to show, so you'll have to just see the result at the end. But we're going to add enemies, and we're going to make them so that we're going to make it so that they can target the other enemies. So they're not just targeting the player, but they can interact with each other, which is really, really cool. I was actually one of the first people to do that on Scratch. So, and it's actually not that complicated. It takes a little bit of math, but we'll get there. Okay, so the first thing we're going to do is I'm going to clean up some of this. So I'm going to actually put the player in a different sprite, and I'm going to get rid of these ugly numbers. And I'm going to get a nice green grass color. Fill it in for all of those. Put some like grass strokes, like anything. Like you can make this whatever you want, but I'm just going to make grass. You could draw rocks on it, you could draw a road, anything that you want, and you can lay it all out on the scroll and the way the scrolling works. Okay, so there's some grass, and because I only have 4 costumes, I need to make this a 2x2 and then get rid of those. So now if we do this again, we have okay, so I need a okay, so we'll see what happens. It's going to be a 4x4 map, and what I'm going to do is I'm going to make a new sprite called player, and we're going to put all the player and rename this to just map. We're going to put all the player scripts in this player sprite. So we're going to put this player movement in and get rid of this. Put this player movement in. Is it in there? This block, this player movement block. And we're going to get rid of this. Wait, where is it? Oh, it's over there. Why is it over there? Okay, so we're... Whoa, that was a lot of lag. Okay, so now we can move this over. So now we have this. And the way we need it to work is we can't have the tick in this sprite anymore. We need to have it in the player sprite. So just drag it over. In here, in the place where that player thing was, you need to hide this. Just put the player blocks in there. Get rid of this. So you should only have this setup, these 2 prep blocks, the tick, receive, and the tile position blocks. In the player, you should have all the other main stuff. So you should have the green flag clicked, setup, and tick. And then, let me zoom in a little bit. Setup, when I receive setup, set the player X. And then, actually, okay, so we're not going to use the receive tick because you can try it. What happens is it creates a little delay. So we're going to put the player movement before the tick. And now, well, we need a sprite for it. Okay, so what we're going to make the sprite, I recommend you make it 30x30. So you can see it up here. It tells you, it's probably hard to see, but it says 42x42 when you make this circle. So I'd try to get it at like 30x30 is about fine. And I'll give it an outline. Just try to make it like around 30. And try to get it as close to the center as you can. And just make it a nice color. And then draw some arms. You want them to be facing to the right. And then just make a little thing, which is going to be a little thing he shoots out of, so then you can make it like rounded. And then put it in his arms, like that. Okay, so that looks fine. And we're going to switch to that costume. Right about here, not cat. And this should be fine. So when we play, it should be exactly the same. Actually, I'm going to decrease the speed to 4 so that he goes a little bit more realistically. And I'm going to decrease this to, like, how should I make this? Like 5 or 4? I don't know, you'll have to play with it. I'll make it 4 or 3 actually. 4. Okay, 4. So we do that, and I'll hide these variables. Okay, so that's pretty good. And now we need to make it so it points towards the mouse pointer. So just point towards mouse pointer. And there we go. So we don't have any bullets yet. We can't shoot, but this is pretty okay. It's starting to seem kind of cool. Actually, I'm gonna center it. I actually try to center it. So you just move it out of the way. Draw a little guide on the crosshair. And then you put this, try to get it centered like that. And then that. So go to the back and then get rid of the crosshairs. So that way it looks a little bit better. I'll just offset it a little bit. Just a little bit. Okay. So that's good. So that probably spent too much time on that. But anyway, so you got this. Now we're going to make a new sprite. And you can just make a new sprite and call it enemy. So now we're going to drag this costume into here. You can make this a little bit of a different color. And so this is going to start to have a similar type of script to this. So what we're going to do is you can just drag this whole player movement into the enemy, and it's going to duplicate it. But this time rename it to enemy movement. And we don't need the keys pressed, so just take all those out. We're going to put something different in there in a little bit later. Okay, so now what we need are some variables. So instead of player X and player Y, we need new variables. Make a variable for this sprite only, and I like to put a dash before these, so enemy X. So it's for this sprite only, and I like to put a dash before the variables for this sprite only, so you know which ones they are. Dash enemy X, and then dash enemy Y. I put the dashes so that they always go to the top of this little list of variables. So enemy X and enemy Y. So we'll take out this this part with the scroll X because we don't want the enemy to change the scroll X. And also we need 2 more variables actually for this sprite only. Dash enemy X vel for enemy X velocity, just like we had the player X vel. And for this sprite only, dash enemy Y val. Whoops. Okay, I did it. So now you want to change all of these variables to the enemy variables. So I'm just going to move this. So you have enemy X val, enemy X val, enemy X val. So change all these, and then these are enemy Y val, Y val, Y val. And then these also change to enemy X val, X val, enemy X val, and then Y val, and Y val. So you change all those. Then the change player X, no, we want change enemy X, change enemy Y by enemy X val and enemy Y val, and then finally go to enemy X minus scroll X, enemy Y minus scroll X, and don't point towards mouse pointer. Okay, so that's that. We will put this to the side. We're going to do more stuff with that later. Okay, now we need another variable for this sprite only called enemy number. This is going to keep track of enemies are going to keep track of which number they are, because we're going to use clones for this. So what we have to do, okay, so we're going to get the setup. When it receives setup, we're going to set enemy number to 0, and then Okay, how many enemies should we make? Let's make 5 enemies. Change enemy number by 1 and create clone of myself. So it's going to create 5 enemies with 5 different clone numbers, because the clone numbers stay the same. I mean, the variables for this sprite only stay the same, remain for all the clones. So so all the enemies will have their own individual numbers, so we can keep track of them all. And then at the end, it's going to be a similar thing to what we did in the map, where we set the clone number to P. We're going to set enemy number to P. Okay, so that's fine for the setup. And now we're going to get a tick when I receive tick. So here, again, it's going to be like in the map. We're going to do if enemy number equals P. Then we're just going to hide, because we don't want the parent sprite to be doing anything. Else we're going to do this enemy movement. Okay, so I think we should do the same as in the player, which is 4 speed, 3 friction. But we're just going to do 0, 0 for now. We'll make the enemies move later. Okay, so now we need a list. So that way the enemies are going to target each other, because like the enemy's going to target me, the enemy's going to target the other enemies. We need to keep track of all of their positions in lists. So we need 2 lists. So make a list called enemy X for all sprites, and then enemy Y for all sprites. Click OK. So we have these variables. We're going to delete all of them at the beginning of this setup. And then when we create the clones, we're going to add just a blank one to enemy X and enemy Y. And then here, when it does the movement, we're going to replace item enemy number of enemy X and enemy Y with enemy X and enemy Y. So if you did this for all the enemies and you clicked the green flag, you would have these positions changing. So actually, let's do that. Let's set enemy X and enemy Y. So before it creates them, we'll set them to like random. Like, what's our player position when we spawn? Player X is what? It's like 600. Actually, I'm going to change this. I'm going to change our spawn point to 300, 400. And I'm going to have this enemy spawn in 100 from there, or 200. So it's going to go 100 to 500 X. You can have them spawn. So this is just going to put them in random positions. So 200 to 600. So if we click the green flag, you can see it spawns 5 enemies in random positions, which is exactly what we wanted. And you can see that, so we need to add enemy X and enemy Y to the lists. And it's going to store all their positions. And when they're moving, these are going to be updating live, which is exactly what we want, because that's how they're going to target each other. They're going to go based off of the database of all the enemies. Okay, so that's good for now. Now we still can't add the movement yet. Now we need to start adding the targeting. So make a new block called find target. Run without screen refresh. Click OK. So put this right before the enemy movement block. Okay, so for this, we're gonna, okay, so the way it's gonna work is, first the enemy is gonna scan the whole map for all the enemies, and it's gonna check the distances of all of them one by one, and it's gonna find the shortest distance to an enemy that it can find, and then that enemy, it's going to figure out what direction it needs to point to that enemy, and then it's going to point in that direction. And then it's going to set a target coordinate, so a target X and Y, which is going to be somewhere around that enemy, and then it's going to try and move towards it. So that's like their game plan. So the first thing we need to do is figure out the distances to the enemies, and we're going to use some formulas here. So we need to check every single enemy. So repeat length of enemy X. Now we're going to need some variables to keep track of which number we're on. So make a variable for this sprite only, just call it -I1. I like to do this a lot. It's just a number for us to count with. It's just a variable for us to count with, so -I1. At the beginning, we're going to set it to 0 and then change it by 1. So we've got 5 enemies, so it's going to check 5 times. And we're going to make a new block, call it distance2, and then add 2 numbers, x and y, or 2 inputs. So this is going to be the block that we use to check the distance to whatever we put in here. So what we're going to do is we're going to put in item I1 of enemy X and item I1 of enemy Y. So what that's going to do is, so say it's 1, it's going to check the first enemy's coordinates. It's going to check the first item in here, and it's going to put them in here, and it's going to figure out the distance to it. And then it's going to repeat again. Because it's going to go 5 times. Then it's going to go to the second enemy, and then it's going to check the second enemy's coordinates. And then we're going to do if that is less than the current target distance, then it sets it. So then it does that over and over until it finds the shortest distance to an enemy. So we're going to need another variable for this sprite only called enemy target distance. It's going to keep track of what the target distance is. So actually what we're going to do is, so what we need to do is going to find the distance, and if that distance is less than the target distance, the current target distance, then we're going to set it to whatever that thing was. So like if, the last enemy was 200 blocks away, 200 pixels away, then here's an enemy that's 150 blocks away. That's the shortest enemy. So now we're going to set the distance to 150. It checks again, and it checks until it gets the lowest it can get. So that's what it's going to do. But at the beginning, we need to set it to something really high just so that it resets it. So what we're going to do is we're going to set target distance at the beginning to an underscore. The way Scratch works is no matter how big your number is, if it's up against an underscore, the underscore is always going to be greater than this. Also letters, like any letter is greater than these numbers. So that's what we do, and it figures it out. So how do we figure it out? How do we figure out what the distance is? Well, it's going to take some math, but there is a good formula. So it's called the Pythagorean theorem. I'll just draw a picture of what it does. It's basically what the distance block, what this blue block does, this distance to block, that it's just hiding here. Like, I don't think anybody uses it, but we can sort of get around it so it still won't be used. So it's called the Pythagorean theorem. So basically, like here's our enemy, right? And we need so here's our enemy, and we need to figure out the distance to the other enemy. We can think of it's like a triangle, right? It's like you can draw a triangle with this, and it's got a sharp corner, right? So if you say this is A, this is B, and our mystery distance is C, then the formula is A squared plus B squared equals C squared. So that's the formula. It's like one of the most important formulas in math that you'll probably be learning soon if you don't know about it. So what it means is, like, let's say that distance is 3, and this is 4. Like, they can be anything, but I'm just giving an example. That's 3, that's 4. We don't know what this distance is. It's a question mark. So we put this in. So A, it's 3. It doesn't matter which order you do this in. So 3 squared plus 4 squared equals our mystery number squared. So and squared means you multiply it times itself. So 3 times 3. 4 times 4. So 3 times 3 is 9, plus 4 times 4 is 16. 9 plus 16 is 25. And now 25 is what squared? So what times itself is, what times what is 25? Well, 5. 5 times 5 is 25. So that's your answer. This is 5. That's how long this is. So if this was 3 feet, this is 4 feet, this is 5 feet. You can just figure out the distance like that. And we can figure out what distances these 3 and 4 are based on its x and y. So that's how we're going to do it. So we're going to take the square root of adding those differences squared. Okay, so what we're going to do is get this block here, take the square root. So it's the square root of, and it's a squared plus b squared equals c squared. So we're going to get the plus and how you multiply things by itself. So we're going to multiply it by itself because that's what squared means. To get the distance, we take our x, which is the x of whatever this was, and subtract enemy x, and then you duplicate that. So that's going to give you the distance. So this is going to give you the distance across x, y's, and it's going to square it. And then you add the other side of the triangle squared. So it's y minus enemy y, and square that. So times itself, and then you square root this whole thing. And that's the distance. That gives you the distance. So you put that in here. So if the new distance is less than the old distance, then we set it to the new distance. Actually, let's round it. So round this new distance so it gets a nice clean number. So we can test this. So if distance, so let's set let's set the target distance to just underscore, so it resets it. Set enemy x to 0 and set enemy y to 0. So if we check the distance to 100, 100, we'll get 141. And that kind of makes sense, right? Because if you're right here at 0, 0, that's 100 over there, that's 100 up here. This distance is going to be longer than those two, so it's like 141 as opposed to 100. So that makes perfect sense. Okay, so that works. So, but what about the player? Because the player's an enemy too. I mean, for the enemy's perspective. So how do we target the player? Well, that's why. So what we need to do is, so the enemy's not going to be able to target itself. Like what happens when the I1 equals the enemy's number. So we can use that to target the player because we might as well. So we're going to use if I1 equals enemy number. Then we take the distance not from the enemy's position but from the player x and the player y. And it's going to find the distance with that. And it's going to put it in the distance block. So we can do that. So that's going to figure out the distance. Now the next thing we got to do is figure out to point in the direction. So we got to point in the direction of that enemy or the player. So, but how do we know which one it was? Because it never stored what it was. Like, how are we supposed to know? So what we need to do is we need to set another little variable. Call it -I2. It's just another random placeholder variable. We're going to set I2. We're going to set I2 to 0 at the beginning. And here, when we set the new record distance to the lowest distance, we set I2 to I1. That's going to keep track of which enemy number it was. That's going to keep track of which enemy number it was. And then we're going to make a new block, a new pink block, and we're going to call this one, run without screen refresh, we're going to call it direction to x and y. Two of those inputs and run without screen refresh. So we have another block. It's going to be similar to the other block. We're going to take the direction to item I2 of enemy X and item I2 of enemy Y. So it's going to remember what number it was from based on this, and then it's going to check it. But we have to do a similar thing to what we did with this, where if the I2 is equal to the enemy number, then it checks the direction to the player's X position, not itself, not another enemy's, because it would target itself, and you can't really do that. Okay, so it does that. Now we need to set up our direction block. So we're going to be given 2 coordinates, and it's going to target. Okay, so the way we're going to do this is harder than the other one. Basically, if you have a triangle and you have this angle, you have an angle, which is going to be your direction. I'll just call it D for direction. So if there's a certain like algorithm called tan or tangent. So you have the opposite side and this adjacent side here, which are the 2 sides that we know. So the way you do it, so this is the opposite side and this is the adjacent side. You find the tangent of your mystery angle is the opposite side divided by the adjacent side length. But we need to figure out what the angle is, so we need to put this tangent over there on the other side. So we need to put it over here and do the inverse tangent. So we need to do the inverse, which is you just put an A in front of it, and that gives you the inverse. So the direction that we want is the A-tan, or the arctan of the change in Y over the change in X. Or actually, it doesn't really matter this time, because I'll show you what's going to happen. So that's our formula, pretty much. And then we have to offset it a little. I'll show you. So we're going to set, we need a new variable. Yeah, for this sprite only, enemy target direction. That's right, direction for this sprite only. Okay, so we're going to set this enemy target direction to, we're going to be dealing with a bunch of decimals, so we're going to round it. So this probably doesn't really make much sense, and it took me like hours to figure out, like, get it exactly the way I needed it to be. So we're going to do that formula that we had, which was A-tan, or the arctangent of, and we're going to divide. It's going to be the change in, or it's going to be this X minus the enemy X divided by the Y minus the enemy Y. Whoops, so we'll put that in there, the A-tan of this. And then what we have to do is, it's only going to give us a certain range of directions, so we have to offset it by if the direction was up or down, was higher than, if the enemy was higher than the target or not. So we need to add an offset. So add 180 times the Y is less than the target Y is less than the current enemy's Y. So this is a cool thing you can do. You can put these greater than or less than blocks inside these round blocks. So it's either true or false. If it's true, then it's going to be a 1, and 180 times 1, it's going to add that, so it is going to add 180. But if it's false, then it's going to be 0, and 180 times 0, it's 0. It's not going to add it. So that's a cool shortcut for how to add things. And we're just going to round this whole thing. So that's our formula. So we can try that too. So we can set we can try a direction. So, but I'm not going to do that right now, because when you do the direction, sometimes it's gonna give you crazy large numbers, like 225 for a direction. But we want our directions to be in the normal range of like 180, and minus 180 is the max and min. So we're gonna add another little offset right here. So we're going to change enemy target direction by, and we can do some more shortcuts with these blocks here. So we can do 360. So if the thing is less than -180, if the direction's less than -180, so if it's like -200, then we're going to add 360 to it. So then this is going to be true, and we're going to add 360 to it. And we're going to subtract 360. We're going to subtract 360 if it's greater than 180. So if you get like 200, we're going to subtract 360 and get a more sensible direction. You just put these back to back, and that's it. So those are all the offsets we need for this direction block, and that's it for the formulas. So that's it. It's going to find the right direction, and then it's going to point to it. So now all we have to do is add a little point script, and I'll do it up here. So it's got the direction. It has the direction. It's going to have the, at this point, it's going to have the direction it needs. So all we have to do is, we're gonna use a similar script to what we do up here with the smoothing script. So how we get the smooth transition for, we're gonna turn. So we're gonna turn like by the difference of the direction, and then divide it by 5. So turn to the right, enemy target direction divided by the current direction. So the gold direction minus the current direction, and then divide it by 5. So at this point, let's try it out and see what it looks like. Yep, look, it's working. So you can see the enemies are targeting me, and if I go away, he targets the other one. This is exactly what we want. You can see they're targeting me. It's really cool. So all they're doing is they're just checking from the list all of the enemies. They're just checking from the list all of the enemies, and then so it's checking to find the distance to the shortest distance to the enemy, and whichever one it is, then it figures out what direction it needs to point there. So that's what it's doing. But that's kind of that's cool, but that's kind of boring. So let's add some movement. So in order to do that, we need to figure out, so we need like a target coordinate for the enemy to zero in on and target. So we need 2 more variables. Enemy target X for this sprite only, dash enemy target Y. Both of them for this sprite only. So what we're going to do after this find target block, we're going to, oops, yeah, I have these pictures of the scripts that I'm using, just as a refresher of what they are, because they're pretty long. Alright, so what we're going to do is we're going to set the enemy target X and Y to whatever this coordinate, whatever the coordinate it zeroed in on is. So that could either be the player's position or the or another enemy's position. So we got to bring back this if I2 is equal to enemy number. We're going to set the target X and Y. So what we're going to do is we're going to set it to this enemy number or the player X and player Y, and then we're just going to add like pick random minus, we're just going to offset it by a bunch. So like -150 to 150. So plus that, and then plus this. And we're going to put these in here and put this. And then we're going to do it like this. So we're going to put the player X and Y in here. So it's gonna pick a target like somewhere around the player or whatever target enemy they're zeroing in on. But we don't want it to do that all the time. We don't want it to just pick a random target all the time. So what we're going to do is we're going to say if pick random 1 to 60 is equal to 1. So every 60 frames, it's going to set the target X to a blank thing. And if the target X is blank, then it's going to pick a new target. It's so and also we're gonna set the enemy target X and target Y to blank at the beginning, like that, or do this, I guess, and also the target direction and distance and direction. Set enemy target direction and distance to blank. Okay, so we have all that. Wait, and what else? Are there any other variables? Oh, the X and Y val. X and Y val, just set those to 0. Like that. Okay, so that should be enough to reset them. Okay, so back to the movement. So either they have a target, or they're not. So, or they don't. So if they don't have a target, it picks a target somewhere around their target enemy or target player or whatever, and every once in a while it just sets the target to blank, so it picks a new target. So that's all it's really doing. Yes, okay, so that's all it's really doing. So now we need to just make it move, make the enemy move based on its target X. Sorry, I'm just kind of rushing to get, because I probably have to go to bed soon. Alright, so here we go. So what we need to do is, so this, actually I'm going to shuffle these around a little bit. Speed times -1. Yeah, that's good. Okay, so put speed up here in the enemy movement. Okay, so what we're going to do is, this is going to move him to the right. So we want him to move to the right if he is to the left of his target. So we're going to get, if enemy X is less than enemy target X, then he moves to the right. And on the opposite side, if he needs to move to the left if he is to the right, or his X is greater than the target X. And then he needs to move up if he is lower. So if enemy Y is less than the target Y. And he needs to move down if he is higher than the target Y. Okay, so let's try that. So that should be everything. So let's try it. Oh, okay, so and also you have to set this. Okay, so I'm going to set them to 4, 3, which is the same. Okay, look at that. You see the enemies? Oh, let's go into a place where it won't be lagging. You see, look at that. They're moving, and they're targeting the other enemies. They're moving around randomly, which is really awesome. You see, they're moving around. They're just picking random enemies, and they're targeting the closest person, which is awesome. But you can see they're kind of jittering a little bit when they're around, and the reason that's happening is because, like, he moves to the right, and then all of a sudden his target is to his left, and then he's jittering back and forth across his target. So what we need to do is we need to add just a little, like, space, like a leeway. So what you need to do is add 10 to this. So in case he's within 10 of his range, then he will move. Otherwise, he's not within 10 of his range. So then you do a minus for this one, and then a plus for this one here on the enemy Y, and a minus on this enemy Y. And now if you go into it, and you should always go into the backdrop, so there's no scripts in here with the yellow border, like with these yellow borders, that lags up your game. So you need to go into the backdrop where there are no scripts, and that makes it smoother. So, and now you can see all the enemies, they're targeting each other, they're moving around really nicely, and they're moving around. It's pretty awesome. They're targeting each other. You can see they can target me, they can target each other like that. They're targeting, he's targeting me, he might move soon. And you can change these up, so you can change up the settings. Like you can change the speed really easily, so you can make them move really fast like that. But that'd kind of be unfair for the player, so just keep it the same. You can make it so they change their target faster. So like this. Like so now they're changing their target faster. If you make it the chance higher, like with 1 to 30 is one, it's better than 1 to 60. Like 1 to 50 might be pretty good. You could make them so they get closer to the player, like minus 30, 30, minus 30, 30. So you can make it so they really try to huddle up to their target if they can, like that. Like you can see they're all huddling up, but that's kind of weird. So I just do like 170. So it gives it like a range of the places where he can target, like he can focus in on. You could also change this, and you can add as many of these as you want. You can have you could have like 20, 25 of these guys, just all targeting each other. It's all really cool. And you can do anything with this. You could have all the enemies focus in on one point. Like they don't have to just target the other enemies. They could target like like items. Like if you drop random items, and they could target that, figure out which item is closest and go to it and pick it up. They could target a specific point on a map that you tell them to. So there's a really lot of cool things you can do with this, although 25 is quite a lot, so I'm going to make it just 5 again. But this is really cool. I'm just really happy. I was so happy when I got this to work, when I got the enemies to target each other. It just makes it seem more realistic, and it's just more impressive and more cool because the enemies can interact with each other. Alright, so that's going to be it for this tutorial. Maybe next episode we'll get the bullets working so you can shoot, and I have another pretty cool way we can get the bullets to work. Alright, thanks so much for watching, and see you next video.